Alright, in these examples down here we're asked to figure out if the following functions are differentiable at c. So let's look back at these three reasons up here why something might not be differentiable at c. First is if it's not continuous at that point. So that would mean there's a hole, an asymptote, or a jump. Another option would be if the right-hand derivative or left-hand derivative does not exist. That means there's going to be a vertical tangent line at c, because the left-hand or right-hand derivative would be infinity, negative infinity, which would give us an undefined tangent line. Slope would be undefined. And the last option is if the right-hand derivative is not equal to the right-hand derivative is not equal to the left-hand derivative, which would mean there'd be a sharp turn at c. So for number one, we want to figure out is this differentiable. First, let's see if it's continuous. We don't have any holes or jumps or anything at c, so it fits the first requirement. It's continuous. Then we want to look at the right-hand derivative and the left-hand derivative. So from the right side, as we get closer and closer to c, remember the derivative is the slope of the tangent line. So we have a positive slope, and that gets less and less steep as we get closer and closer to c. And at c, it's approaching a slope of 0. So we have a positive slope, but it's approaching 0. On the left-hand side, we have a negative slope, but as we get closer and closer to c, again, that slope is getting less and less steep, and it's approaching a slope of 0. So our right-hand derivative is going to be 0, and our left-hand derivative is going to be 0. So from both sides, we're approaching a slope of 0. So they're equal and they both exist, so yes, this is differentiable for number one. For number two, it's continuous. There's no holes or jumps or asymptotes at c. Right-hand derivative from here, if we're assuming this is just going to be a regular absolute value graph that's just been shifted, this would have like a positive slope of 1 most likely. And then here we would have a slope of negative 1. But the difference between these is that it's not gradually getting to be the same at c. It's always negative here, it's always positive here, it's not transitioning, it's not going to be 0 at this point. Here we have a sharp turn. So this is where the right-hand derivative and left-hand derivative are not equal to each other. So this one is not differentiable at c. And then number 3, for this one, left-hand slope is positive, and it's gradually getting less and less steep as we approach c, and it's approaching a slope of 0. Right-hand derivative, positive, as we get closer and closer to c, less and less steep, and approaching 0 as well. So for this one, yes, it is differentiable.